I told you guys I recorded this earlier, but I just wasn't happy with it. But I have to say this. So far, I'm happy with this. Is it making sense so far? We were all good so far? Okay. Now look, I've got 3 steps here, but I actually want to read the example, and then we'll go look at the 3 steps. Okay? Now, Drew, example number 3 says, use a table of values to graph the equation 3x plus 2y equals 1. Okay? Now, we're going to do that, but here are the steps that we're going to use. Step 1, rewrite the equation in function form if necessary. So when we look at this equation, is it in function form right now? It's not, right? Because remember, function form has y by itself. Okay? So I'm going to rewrite it. 3x plus 2y is equal to 1. What should I do first to start moving toward function form?
Subtract 3x.
Subtract 3x, and I'm going to get 2y is equal to 1 minus 3x. Now what? Divide by 2, but that means divide everything by 2. This divides by 2, this divides by 2, this divides by 2. So now I've got y is equal to 1/2 minus 3 over 2x. Do you mind if I write the fraction out to the side? Is that all right?
Yeah.
Okay. Now let me ask you something, Drew. Is this it?
No.
That's not it. You're right. What's the problem?
You want to have negative 3 over 2x in front because it has the variable.
Exactly. So we want to write this in a different order. Y is equal to negative 3 over 2x plus 1/2. Now it's in function form.
Yes.
Perfect. Perfect.
It says to
Now that was step 1. That was step 1. Rewrite the equation in function form. Step 2 says choose a few values of x and make a table of values. And we definitely want to choose 3. 4 is too many. We don't need to do 4. But 2 is not enough. Because remember, when we graph this, it's going to be a line. If I do just 2, one of them could be wrong and I wouldn't know it. But if I do 3, then they should all be in a row, if it's right. If they're not, then I must have made a mistake somewhere. So we're going to do 3. Okay? Now, a table of values just looks like this T-chart, x and y. And I can choose any x I want. I can choose 6 trillion. I can choose negative 2.9. I want to choose nice, easy numbers that make it simple for me to evaluate and plot. Right? I don't want to choose 6 trillion because then I have to draw a graph with 6 trillion on it. Okay? What do you think, Cameron?
9.
Cameron says 9. I'm actually going to ask him not to use 9. And the only reason is because I don't need my graph to be that big. I don't need a graph, I don't need x to be 9. I could choose negative 1, 0, and 1. I could choose negative 2, 0, and 2. I try to choose a negative. I like to choose 0. The 0 always makes this one just go away. Because 0 times that number will give me a 0, right? And then I always like to choose a positive. So let's try again, Cameron. What else? What else do you think?
Negative 4.
Okay. Cameron says, let's choose negative 4. I like that one. What else should we choose? Anybody have another one for me? What do you think, Evan? 0. That's going to be an easy one. All right. And now what else? Anybody have another one for me? Steele. Okay, Steele says positive 1. Okay. Now, we just plug these in. Let's do y is equal to negative 3 over 2 times negative 4 plus a half. All right? I just plugged in negative 4 for x, and it's going to spit out what the y is. Y is equal to positive 12 over 2, or positive 6, plus a half, or y is equal to 6.5. So if x is negative 4, y is 6.5. All right. Then I'm going to plug in 0. Y is equal to negative 3 over 2 times 0 plus a half. Y is equal to a half. Right? Because this just turns into 0. That's why we like using 0 too. Right, Andrew? So now y is a half. Okay? And then the last one, here, let me scoot down. Y is equal to negative 3 over 2 times 1 plus a half. So y is equal to negative 3 over 2 plus 1 over 2. Y is equal to negative 2 over 2. So y is equal to 1. Nice. Okay. Oh, I'm sorry, negative 1. Thank you. All right. Now, I need to graph it, and I'm running out of time. We'll do that on the next video.